Earthquake regions and disasters. Understanding where earthquakes occur and their devastating impacts across different regions of the world. Africa's earthquake activity. Generally safe, Africa is largely free from earthquakes except along specific edges and zones. Edge activity. Morocco, Algeria, and Egypt experience seismic activity along continental margins. Rift Valley Zone. East Africa's Rift Valley experiences significant earthquake activity. East African earthquake history. December 1910. Major earthquake struck Tanzania near Lake Tanganyika shore, causing significant damage. January 1928. Kenya experienced a major earthquake, highlighting the region's seismic vulnerability. West African seismic activity. Ghana's Accra region. The only part of West Africa experiencing regular tremors since the second half of the 18th century. Significant activity. Recorded in 1906, further highlighting the area's seismic vulnerability. Major tremors. Occurred in 1867, indicating early seismic activity in the region. Notable earthquake. Struck in 1937, causing concern for urban earthquake risk. Nigeria's recent activity. Basement complex areas. Minor earth tremors recorded in recent years, particularly in Oyo and Ogun states. These tremors indicate emerging seismic activity in previously stable regions. Alaska's devastating 1964 earthquake. Magnitude 8.5 on scale. Massive earthquake that struck Alaska in 1964. Epicenter 120 kilometers from Anchorage. Despite the distance, Anchorage was severely damaged, demonstrating earthquake power. The earthquake process. Accumulation of stress. Tectonic plates are constantly moving, causing immense stress to build up along fault lines in the Earth's crust. Rupture and release. When the stress surpasses the rock's strength, the fault ruptures suddenly, and the stored energy is released as seismic waves. Elastic deformation. Rocks on either side of the fault deform elastically, storing energy much like a stretched rubber band, until their strength is exceeded. Ground shaking. These seismic waves travel through the Earth, causing the ground to shake, which can lead to widespread destruction and aftershocks. Understanding earthquake origins. Focus point. The point in Earth's interior where earthquake vibrations originate. Wave radiation. Waves radiate upward as underground body waves in concentric patterns. Surface impact. Waves reach the surface as surface waves in concentric circles. Focus versus epicenter. Focus. The actual point inside Earth where the earthquake originates and energy is released. Epicenter. The point on Earth's surface directly above the focus where shock waves first hit. Measuring earthquakes. Seismograph. The specialized instrument used to measure earthquake intensity and record vibrations. Types of shock waves. Body waves. Travel through Earth's crust. Surface waves. Travel through surface rocks. Body waves explained. Primary waves. Cause coastal rocks to move backwards and forward in the direction of wave movement. Secondary waves. Cause coastal rocks to move side to side, at right angles to wave direction. Primary wave movement. Primary waves create compression and expansion as they push rocks back and forth in their direction of travel. Secondary wave movement. Secondary waves create shearing motion, moving rocks from side to side perpendicular to wave direction. Surface waves detailed. Love waves. Cause surface to move side to side at right angles to wave direction movement. Rayleigh waves. Cause surface rocks to have vertical circular movement patterns. Love waves in action. Love waves create horizontal shaking motion, moving the ground from side to side perpendicular to the wave's direction, making them particularly destructive to foundations. Rayleigh waves pattern. Rayleigh waves create a rolling motion similar to ocean waves, with vertical circular movement of surface rocks. Wave types comparison. Primary. Forward-backward motion through crust. Secondary. Side-to-side motion through crust. Love. Horizontal surface movement. Rayleigh, circular rolling surface motion. Effects of earthquakes. Structural damage. Earthquakes can cause severe damage to buildings, leading to collapse and making structures unsafe. Cracked infrastructure. Roads, bridges, and other critical infrastructure can suffer extensive cracking and displacement. Emergency response activation. Large-scale earthquakes necessitate immediate and coordinated emergency responses for rescue and relief efforts. Understanding seismic impact. Wave generation. Energy releases from focus point creating multiple wave types. Surface arrival. Different waves reach surface at varying speeds and intensities. Structural impact. Combined wave effects cause devastating damage to infrastructure,